Hi there guys, in this video we are going to look at capacitors, how they work, where they are used and why they are important. Remember, electricity is dangerous and can be fatal, so make sure you are qualified before working on electrical system and never touch the terminal of a capacitor because it can still hold a charge and give you an electric shock. A capacitor is a component that stores electrical charge. It's similar to a battery, but it stores energy in a different way. It can hold as much energy as a battery, but it can charge and release its energy much faster. That's why capacitors are found on almost every circuit board. To understand how a capacitor works, imagine a water pipe with water flowing through it. The water flows until you close the valve. Now imagine that after the valve, the water flows into a tank. The tank stores some water, and when we shut the valve, water still flows out for a moment until the tank empties. As long as the tank is not completely empty, we can open and close the valve repeatedly and still maintain a smooth flow. In electrical circuits, the capacitor works just like the tank. It stores energy and releases it to smooth out interruption in the power supply. If we turn a simple circuit on or off very quickly without a capacitor, the light flashes. But we add a capacitor, the light remains on briefly during the interruption because the capacitor discharges and powers the circuit. Inside a capacitor, there are two conductive metal plates separated by an insulating material called a dielectric. The dielectric becomes polarized. When exposed to an electric field, one plate of the capacitor connects to the positive side of the circuit and the other connects to the negative. When connected to a battery, electrons are pushed onto one plate and accumulate there. While the other plates lose electrons, electrons cannot pass through the dielectric, so the capacitor charges until its voltage match the battery voltage. Now there is a difference in charge between the two plates, and that creates a voltage we can measure with a multimeter. Just like opposite poles of magnets attract the negatively charged, electrons are attracted to the positive atoms on the opposite plate. This attraction forms an electric field that holds the electrons in place. If we connect a lamp across the capacitor, the electrons will flow through the lamp, lighting it up. This continues until the charge equalizes and the voltage drops to zero. Capacitors come in many shapes and sizes on circuit boards. Larger ones are used in motors, ceiling fans, air conditioners, and for power factor correction in buildings. Each capacitor has two main ratings. Its capacitance measured in farads, and the maximum voltage it can handle. Exceeding this voltage can cause the capacitor to explode. To check the voltage on a capacitor, set your multimeter to DC voltage. Connect the red lead to the positive side and the black lead to the negative side. If the reading is still high, you must discharge it safely using a resistor. To measure capacitance, switch your multimeter to the capacitance mode and connect the leads. The reading will usually be close to, but not exactly, the value printed on the capacitor. Thanks. It's for this video. To keep learning, check out the next video on screen. Thanks for watching, and I will see you in the next lesson.